All right. So thanks again for being here with us today. It's great to have many of you with us, and we look forward to learning more about quality engineering, opportunities across industries, and the hidden advantage. My name is Cynthia Eden, and I'm the Program Development Manager for the Quality Engineering Microcredentials with the School of Continuing Studies at the University of Guelph, and it's great to have you here. Before we get into our main conversation, I'd like to spend a moment to just acknowledge the land and space in which we learn, work, and research. And so here we offer our gratitude to the lands on which the University of Guelph campuses are situated and the Indigenous ancestors who have inhabited these lands for centuries. We recognize that our campuses are located on the lands of the Dish with One Spoon Wampum and the traditional lands of the Haudenosaunee, Anishinaabe, and Huron-Wendat. We offer our respects to these nations and to the diverse communities of First Nations, Inuit, and Métis peoples who now reside on these lands. We also recognize that our educational and research enterprises occur on Indigenous lands across Turtle Island and Mother Earth, and we endeavor to ensure our activities honor and respect Indigenous peoples and their lands. So with no further ado, I'm going to introduce our speaker today, Hussien Hegab, who is an assistant professor of mechanical engineering at the University of Guelph in the College of Engineering. I'm going to let Hussien explain a little bit more about his experience before he moves into his conversation on our topic today. Thank you, Hussien.
Thank you so much, Cynthia, for the introduction. And I would like first to welcome everyone for joining us in this webinar. Before starting and talking about the quality engineering opportunities that we are trying to address here with the School of Continuing Studies and College of Engineering, let me introduce myself. My name is Hussien Hegab. I'm Assistant Professor of Mechanical Engineering at the College of Engineering in University of Guelph. My previous experience, it's not only academic experience, I have been working in the industry as well. After I got my PhD from Ontario Tech University in Oshawa, I have been working in the National Research Council of Canada in the Aerospace Manufacturing Technology Center for quite a long time, helping people who are working in the machining industry to utilize the process from different perspectives, like quality perspective, performance perspective, and sustainability perspective as well. After this, I joined Canadian Nuclear Laboratories as Operations Research Analyst before joining the United Arab Emirates University as Assistant Professor in Mechanical and Aerospace Engineering Department. And recently, like almost 2 years ago, I joined College of Engineering as Assistant Professor of Mechanical Engineering. That's a brief about myself. If you're interested to know more about my experience, definitely feel free to drop me a message or send me an email. You are more than welcome to do this, and we can also discuss any question you may have. Regarding today's agenda and the purpose of this webinar, we will be talking more today about what is quality engineering and why quality engineering is important for not only a particular industry. We are going to talk about different industries, and what about the hidden opportunity that the industry, that the quality engineering might be offering to us and we don't know. These are the topics or the points that hopefully we will cover today. At the end of this, I will talk to you about a new developed micro-credential that we have developed here at University of Guelph. As I mentioned, that was a partnership between the School of Continuing Study and the College of Engineering. And this has been established not only for academic purpose, but mainly for people who are working in industry and they don't have time to develop their skills in this field. We will end up this with a QA session. Let's start. The first thing we would like to talk about today is what is the hidden cost of for any business? Like usually, people who are working in different sectors or different industry, if things are moving slowly or even faster, but it's moving, they said, okay, my organization is doing good. We don't have a problem, but they don't recognize that every day every organization, they lose time and money, and this is maybe would not have a clear impact on their process or their operations. And this is what we can call it the hidden cost or the hidden opportunity. This might come from different things like waiting and unnecessary approvals, and I don't recognize this waiting, by the way. It might be because of downtime that happened to one equipment or a machine that even I don't know the reason, but once it has been fixed, I'm not looking into what is the cause of this downtime or what is the problem that make this equipment that is not working. Rework and defects, many defects happening. As long as I got 8 or 7 out of 10 parts, they are good, I'm happy, but I don't care about what are the source of these defects or even spending more time to rework them. That is another way. Another also source of the hidden opportunity or the cost in the long change over time when I'm switching from a shift to another shift, if I'm talking, for example, about manufacturing industry, or even when I'm talking about any service industry, hospital or restaurant, when I'm trying to make changeover between shifts, sometime this changeover like is done through long time, and there is no standardization for this. Some repeated task which is not necessary to be done or duplicated effort. That is another way of this hidden opportunity or cost. And one of the most important things also in all industries is the poor communication, which may cause delays, and definitely it will add another layer of waste. One also of the challenges that many people maybe the overlook is we depend on individual experience, and once this individual experience are not available anymore, we still need long time to get this experience again because of like lack of what we call it standardization. So all these aspects happen every day in many business and organization, and we don't take advantage of this. Rather than we take advantage, these things take advantage from our business, and that's why we are here today. So if we would like basically for you to understand the concept, the real problem usually is that the waste is invisible. But the cost is real. So the problem here that the waste I'm talking about in the previous slide, it's invisible. It's very hard to recognize, but its cost is still like real, and it's eating from what I have in my organization. And the question here, basically for quality engineering, and that's why we are here today in this webinar, what if your organization was able to identify this waste, first of all, and then try to develop methods and strategies to eliminate this waste without even just buying a new equipment or asking my manager, I need this amount of money or this cost to improve the performance. You are not just talking about a new investment, but you are talking about a tool. You are talking about a science. You are talking about a knowledge that I will bring to you. And then from this, we will identify the waste. We will eliminate this waste, and we will eliminate this hidden cost from us. And that is the real things that we are caring about when it comes to quality engineering. And that's why we are here today. The point is, again, we don't need to make a huge investment. Rather than this, we need to know where is the hidden opportunity. where are the waste in my organization, and what are the appropriate method to eliminate this waste. So simply speaking, very simply speaking, quality engineering, it's not only for engineers, it is just about finding mistakes or finding waste. Uh, it's also about designing better process or better operation to avoid having this mistake or this waste from the first place. So I'm not gonna make trial and error for days or weeks or months until I will figure out. No, I will have a clear method, a clear process which are existing, but you need to know them to identify this waste and eliminate this mistake from your place, and that definitely will impact a lot from the cost perspective. During this webinar, I'm going to use the steps with you, and that is a very simple equation. As I mentioned, this quality engineering aspect, it's not only for engineers, anyone, if they decide to invest some time, which is not a lot, to understand this topic and apply it in their workplace, it's easy to be done. So basically, as we can see here from this equation, we can see 5 steps. First step, which is identification, and we will see this in depth in later slide. Then the analysis stage, then the improvement stage, and then the standardization stage and sustain stage. So as we can see here from this equation, it's very important before looking into the mistakes and waste and try to eliminate it, is how to identify it. And that is not an easy task, okay? Then using some method, you need to analyze these mistakes in order to find a way to improve the current state and try to eliminate this waste. Some people, they thought after improving, here we go, I catch the waste, I already try to get a method to eliminate it, and I improve the system or the process. But this is a big mistake, because after you improve the system by eliminating the waste, you need to find a standard way on how to keep this improvement in action. And this is one of the biggest mistakes when people just identify, define, make kind of analysis. I improve the system, but maybe after a week, after months, after a year, things will get worse even. So standardization, this is something very important, and not only standardization, the sustainability or the sustain point in the equation, which is very important term and element in this equation to keep it sustained. I hear this from many friends that in different industries, I'm going to talk, for example, about the manufacturing industry, quality engineers or quality control people, they are working as a firefighters. But this is a misunderstanding on what is quality engineer. So instead of working as a firefighting, which means trying to act when you find a problem, you need to change the way of thinking using quality engineering and try to engineer it out and try to be proactive, not waiting until the problem happens, not waiting until I see like a huge thing that's affecting my entire process and start to act. This can be done by finding, as we mentioned, waste. One of the examples of the waste here is what we call bottlenecks. Bottleneck, usually this is the most important or the most annoying process in my place. And usually, maybe many people do know this, where is a bottleneck, but they don't understand what are the causes or the root causes for the problem that this bottleneck creating. This is something also from the identification step that we mentioned, is to identify where is the root cause. So even if you know, for example, I got this machine is not working because it does have a problem in one of the parts. So you need to look into why this part is degrading or why this part is frequently failed, and go in depth more and more until you know what is the main cause of this. That will help you a lot. That will help you a lot in the future. Also, reduce variations. Variations here, I mean, like if you are producing something with if you are offering a certain service. Let me talk now about service. For example, you are trying to offer a medical service. So this service should be offered every time with the same standards, not with different levels. And this is what we call it variation, because that will impact the quality of the product or the quality of the service that you are offering. Eliminate unnecessary work. For example, I have been asked to do this part. This part should have certain options, but I add extra option. But this extra option doesn't make any sense to the customer, right? So you need to eliminate any unnecessary work that will not add any value to your product or your service or your process. Improve the process flow, and this is something very important, and it's related to eliminate unnecessary work. And finally is the standardization of the successful practice. Once you improve the system, once you know, yeah, we will do 1, 2, and 3, and this is after we identify the problem, you need to find a way that make this standardized, which means if Hussein can do it, others also can do it, okay? So we will not rely on an individual experience. Once you do this, you need to sustain this improvement over time, and you need to find a way to make sure it will be in action for a long time. Why this, or why does this matter to you? That is one of the questions. When I was trying to get ready for this webinar to you guys, I was thinking about who cares? Why does this matter to me? Because again, we need to stop. You need to stop being the person who fixes a problem. You are waiting until problem happen, and you are trying just to fix them, or you are trying to just wait until it happens and fix. So you need to change this and try to be a person who prevent the problem from happening. I'm not gonna wait until the problem happens. I'm gonna offer a way to prevent this from happening, and this is how it works when it comes to quality engineering. So quality engineering gives you this mentality by having a certain steps, which is, for example, here I will go through them briefly, and as we go in this webinar, we will talk in depth about these steps. For example, save time, labors, material cost, improve productivity, measure your improvement, and this is something very important. Once I identify the problem, I create a design that saves time, labor, material, and cost, and get already improvement. Something that is many of us are like sometimes we overlook this one. Did you measure the improvement? Like, did you have a clear metric on how to measure the improvement? This is something very important, because if I have a clear metric on, for example, I save time by 15%, I improve utilization by 20%, you should know this very clearly. What are the metrics I should use, and I should have this documented, because if I save 15% this year, so my target next year should be 25 or 30. When I'm going to talk to my manager, to the business owner, I will let them know what are the expectations. This is something we need to take into account. Also, the demonstration, how this impact, and you should have evidence and numbers. And finally, this is for your career. You advance your career from different way of thinking of for the person who are fixing the problem to the person who are trying to prevent the problem from happening. So now you have a brief idea on how quality engineering works, but the problem is always where is the waste? We agreed that we need to identify the waste. We need to know where is the waste, what are the sources of the waste. The waste, whether you are manufacturing a product or deliver a service, you can find it in different ways. For example, here, machine downtime, now machine's not working for any reason, so the entire production line will be stopping. excessive setup time. I need lots of time, a long time to set up a machine. And this is only because I don't have a standard process on how to do this. So I'm going to spend maybe 20 minutes, 30 minutes. Next week, I'm going to spend 1 hour. There is no standardization for this. That's a waste. Unnecessary movement. My workers or my engineers or my people who are working on my organization, they don't have a clear way on how to do the process. So they are doing unnecessary movement because there is nothing clear for them. Defects and rework, and this is consequence of all downtime, setup time, unnecessary movement, and finally the material waste itself, which is when we are talking about waste, people think about we are talking about the physical waste. Waste here can be time. Waste here can be unnecessary work, right? Waste here can be work that doesn't add value to your product or your service. Another example for waste when it comes to service, excessive approvals, right? I need to get approval from this and this and this. That might be, yes, correct, but some of these approval might not be needed. Repeated data entry, that's another example. Waiting for information, and that might be done instantaneously. Inconsistent procedure or non-standardization again. Delay customer response. So as you can see here, I put this in purpose just to let you know that you can use quality engineering whether you are manufacturing a product or even you are delivering a service. And this is the beauty of applying quality engineering across different industry, as you can see here. But the question is, guys, do we have waste? This is not the right question. The right question should be, how much are we losing because of this waste? That is where the business owner will care about. The business owner will, after this webinar, you will go to your your business owner or your manager. I got this quality engineering. I need to find the waste in my place. This is not the right way to act. The right way to act is you need to know how much are we losing because of this waste once you identify it, because you need to set priorities, right? And can we measure, quantify, and eliminate this waste? Because it's not only identifying the waste, but you need to identify the most impactful waste, the waste that really impact your place. And you need to see whether you are you able to measure this waste, quantify this waste, because if you cannot measure or quantify this waste, again, you will not be able to see whether you have done or you will be doing a right improvement or not. So again, take care of this point. When you are looking for the waste, don't just look into do I have waste or not, but look for how much are we losing because of this particular waste, or can we measure, quantify, or eliminate it? This is again the same continuous improvement cycle that we have mentioned. Understand, and this is based on your experience in the field you are working on. Measure, collect the data. The data can help you also identify the waste and can help you also let you know which waste is more impactful on your process. Analyze this one, find the root causes. Analyze doesn't mean I will look from the high level. No, I will go deep, look into every piece of waste, see its real impact, what is the main causes for this one, until I will find exactly the cause that I can work on to eliminate it. Once I eliminate the waste, I'm redesigning the process, as we can see here, and this is the improvement stage. Standardize the process and sustain the process. And as we can see here from this quality engineering approach, it's a loop or a continuous improvement loop, as we can see here. I believe now maybe it's time to see some scenarios. I have been working in this for quite a long time, not only in academia, but in industry. And definitely, I'm not going to mention names or companies. I just try to brief some of the work I have done it as a consultation in the past using very basic quality engineering tools, by the way. So this is production example. I have been doing consultation for a packaging company. who have workers working for long distance between stations. The problem was clear for me when I have seen this. The waste here is the unnecessary movement that's wasting labor time. And if we were able to reduce this one, the productivity might be increasing. And at this time, one of the engineering or quality engineering tools was, okay, let's try to redesign the workstation layout using some quality engineering principles that we are covering in our micro-credential. We call it the work study. We are trying to change the motion using some standards. We are trying to set time for each operation the worker they are doing and removing this unnecessary movement. The result here was approximately 18% reduction in walking distance, and that is almost 120 labor hours saved every month. As you can see here, that was our metric that we used to measure the improvement. And that is for sure like save lots of money just for a mini project we have done using quality engineering. And we didn't bring any new equipment, just apply some of these tools with understanding, and we were able to catch this. Another example also here, which is from different industry, without just going with more details, that was manufacturing industry. They were having many times they are doing changeover, and they need to set up the machine in different configuration, and this setup time every time it does have high variation. So sometimes they do the setup in 30 minutes if they do have X person who are very fast and they do this accurately. The second shift, they do have another one who took at least 1 hour to do this. So it doesn't matter. It doesn't matter who is doing this. We start to make a standardization for this process. We observe the process. We observe the time. We analyzed it. We redesigned the process, and we come up with a standard process that anyone should follow this steps to make standardization for this process. The result, we have 3 minutes saved per part. That is not for the setup time. For the entire part that's produced in this production layout, we save 3 minutes. I believe at this time it was 18 minutes, and we take it down to 15 minutes to produce this one, only with this standardization, not for the process itself, but for the setup time that we are doing for some of the machines only. And that is in different metrics, that is almost plus 300 hours recovered from this. This again, without buying any new machine. Okay. So yeah, I'm just trying to give you examples here. And from those 2 examples, we need to know that we need to pick the right KPIs. So quality engineering also show you how to pick the right KPIs or the key performance indicator. These are some of the indicators for production industry. These are also some indicators for the service industry. But it's very important to know what are the metrics, what are the key performance indicators you should use, because the principle here, guys, is if you cannot measure it, you cannot effectively manage it. That's very important. That's very important. You need to measure it very accurately in order to manage it effectively. Also, if you cannot sustain this improvement, it was never a true improvement. So as we mentioned, if we stop at improve, so that is not a true improvement. You need to make it standardized, and it will not be standardized without picking the right key performance indicator. And yeah, this is a time to say, okay, it's not about making improvement, how to sustain this improvement and keep it running for a long time. This is also can be done using quality engineering principles. For example, using visual management or employee training or continuous improvement principle, the loop I just mentioned a few slides ago. Now, since we got idea about this, what we are offering here, almost 1 year and 8 months, we start to establish this micro-credential with the collaboration of the School of Continuing Studies. And we said, okay, we couldn't find somewhere people that are offering micro-credentials that are focusing on what we have mentioned here. Many of these micro-credentials that are available online are very well respected. However, they are focusing on many tools, and they don't have the clear path on how to take it into place. So we offer here at University of Guelph 3 micro-credentials that will take you one by one to apply this in your workplace the next day. And I mean it the next day. First of all, the first level here, we call it Applied Foundation of Quality Engineering. This is where you understand the quality and identify problems. The second level, it will take you slowly once you know where to identify the problem, where to identify the waste, and how to analyze this, is to understand the risk and analyze the customer needs, the failure, make deep root failure analysis, and what are the costs that's related to the quality improvement you are targeting to do. And finally, which is engineer the improvement, the standardization, the sustainability, and this is all the 3 levels that we are offering here in our micro-credentials. Almost everyone will take around 15 to 20 hours, and this is fully online. You can do it at any time, and it doesn't offer theoretical aspect. It's all based on training. It's all based on real scenarios, and you are working with numbers. You are applying these numbers and see, it will not take you to the next tool until you digest this one and you have a full case studies how to use this tool and where to use this tool in your workplace. Definitely this will take you from being firefighters as a quality control or quality engineer to be a quality and continuous improvement professional. As I mentioned, the good point that you can learn it today and apply it tomorrow, because again, the content itself, the exercise itself, the cases itself, it's all about a real problem, real scenarios that take you to analyze the data and work on building this expertise. So instead of like many other micro-credentials or certificates, they are just saying, I have this title, I'm certified this, or I'm certified this by remembering the quality tool. Our micro-credential is a bit different. It will help you answer this question. Can you use this tool to improve a real process? And this is how we establish this micro-credential. Using these, again, 6 steps: and identify, measure, analyze, improve, control, and sustain. Maybe one of the questions, and I will open the Q&A session to get your question, but after completing this journey, like what I can take back to my organization. So basically, you will be able to have good skills about process improvement, identify waste, bottlenecks, inefficiencies. So you will have a good idea on how to identify this and what are the methods to do this. Quality analysis, if you would like to make a tool that identify and eliminate root causes, also you will be able to do this using many tools in our second and third micro-credential. Also, you will be able to anticipate failures before they happen using the risk management methods like failure mode and effect analysis method we are covering. Data-driven control, everything will be data-driven based on the data. You will learn what are the KPIs that you may use to monitor your process and to make sure your process is in control using the SPC method. Lean improvement as well, how to reduce unnecessary work and improve process flow. That's something already covered in different contexts in our micro-credential. And finally, how to establish what we call it work study, improve motion, methods, and task times. That is also we are offering here. And finally, the biggest umbrella here, especially concentrated in the last micro-credential, is to connect operational improvement to your organizational goal. That might be a bit strategic or a bit at a high end, but you will reach this one by end of these micro credentials as well. Now, this is the benefit for your organization. What is the benefits for your career? The benefits for your career is that you will not be the person just that is only like is trying to prevent the problem or trying to act when the problem happening. You will be able to take your organization to answer this question. Where are we losing money from identification of the waste? Why is the process slow? You will be able to answer this from the root cause analysis. Why are defects occurring? Also from the root cause analysis and other failure mode and effect analysis techniques. Where is the bottleneck that we need to invest more time on this because that is priority? What should we measure using the right KPIs? What is the root cause itself? And how much did we improve? How do we make sure the improvement lasts? So instead of just being the one that are fixing the problem, you will be able to identify this. The business impact is clear, like with very small improvement. And again, I'm concentrating on this in my consultation. We don't need to make a huge investment, just some mini project or small improvement. It will accumulate. I'm applying failure mode and effect analysis for this method. I'm applying work study for this method. This small improvement will take the waste to lower side, downtime, lower side, and make productivity, capacity, profitability to higher side. And that's why quality engineering turns operational problem into measurable opportunities. Again, your competitive edge that you will not be, or your organization, again, guys are not looking for people who are simply identify problem. Even if you are looking for jobs in this field and you are trying to improve your training and get more understanding, they would like to find someone in an interview stage that can see the problem, understand the cause, measure the impact, engineer the solution, prove the improvement using the right KPI, and make it sustainable. And this is how these quality engineering tools will take your mindset from different for different perspective. And this is the real value for quality engineering. Finally, regarding our micro credential, as I mentioned, it's not theoretical one, it's practical, applied, measurable. It's not just a theory. You will learn tools, case studies, so you will not just see some theory only, but you will be working on practical cases. It's not just quality inspection, learn how to engineer the process better. This is the main goal on how we design this micro credential. Not just improvement, but it will let you also know how to measure and sustain your improvement. And it's not a course you are taking. This is something or a skill you are trying to improve and building a complete QE capability. And the good point is still, like, we designed this one in a way starting from level 1, that is, even if you don't have a clear experience, or even if you have an experience or you have some knowledge but you forget about it, still you can take this micro credential. Again, this is just to wrap up this. We start with understanding the quality, quality control, and risk and compliance. This is the second one, to prevent and analyze the failure. Simply speaking, this is the output from the second micro credential. The third one, we improve and transform the process. And this is how we create or establish this micro credential. My final message, and sorry if I took for a long time, it's almost 40 minutes now. So every organization has waste, and hopefully you understand by end of this webinar what is the waste, whether you accept it or you engineer it out. So accept it means I don't care, I have it. Once I have it, I will try to fix it. But here we are not trying to accept it. We are trying to prevent it from happening by engineer it out using quality control. And this is maybe the message that you can take out of this webinar. that we are not only waiting until the problem happened, but we are trying to act before the problem happened to prevent it using our quality engineering tools, starting from identifying the problem, looking at the data available, find the root cause and establish the solution and having a measurable result. And this is what we will lead to a sustainable improvement. Yeah, that is maybe that is the end for what I have today for you for this webinar. I will now go back to Cynthia.
Thank you, Hussien, for your presentation and your overview of quality engineering, and in particular, the cycles and what we're trying not to do. Perhaps we've had habits around being the firefighters, but moving away from that reactive response into being proactive, and also not just acknowledging, yes, we know that there's waste, but more importantly, how can we move beyond just trying to see if there's a fix for that waste or that inefficiency, and also to be able to see, what are the consequences of that? Like, what are we losing? How do we measure those things? And moving toward and not stalling with just the improvement, but moving forward through standardizing things as well as sustainability. And so, again, thanks to those of you who are here. Some of you might be thinking of questions at the moment. And as you're thinking, I just wanted to let you know that if you just wouldn't mind going back just for a moment, Hussien, there, the QR code here for those of you who may be interested in learning more about the micro-credentials Hussien has briefly shared about. This will take you to our Quality Engineering Micro-Credentials website at the School of Continuing Studies. If you'd like to learn more about that, gives you descriptions about each of the items. And so now I'd like to open up the floor for any questions. Remember, we do have a question, I think, here. Astrea, one of our business developers, has also added some information to the chat there if the QR code doesn't work for you. So I'd just like to open up things to any questions that people may have. Please feel free to add those to the chat or to the Q&A function. And while we're waiting, I just had one question I wanted to ask Hussien. You spend a lot of time distinguishing the roles of firefighting around becoming not just problem solvers, but initiators of new processes, new ways of thinking. And so I'm just curious, what makes quality engineering in general a little bit different or unique, perhaps, from quality assurance in some ways?
Yes. So that's a good question, Cynthia. I believe there's misunderstanding usually when we are trying to distinguish between quality engineering versus quality assurance versus quality management versus quality control. That is kind of people think this is the same concept at the end of the day. It is related to each other, but it's not the same concept. What I can tell, quality engineering or quality assurance is part of quality engineering, which means quality engineering, this is a bigger umbrella. In quality engineering, we are not focusing only on identifying the waste and finding a problem and trying to solve the problem that is caused by this waste. We are trying to look into the entire cycle, if you remember the continuous improvement loop. Quality assurance, this is part of this continuous improvement loop. That is, once we identify the waste, we analyze the data, we come up with an improvement way, or we redesign the process. For example, what are the techniques that we should keep in mind in order to assure that these improvement or these results will be sustained for a long time, or what are the action I should take into my consideration, or I should do it in order to make sure that this quality that I established through the improvement process, it will still remain as it is for as long as I can. So yeah, that is briefly the difference. Quality assurance is still part of the entire quality engineering cycle.
Thank you very much. We have a few questions here in the Q&A. The first question is, can quality engineering be pursued as a sole career? And can it be switched between industries, like a quality engineer working in the software industry switching to the manufacturing industry?
Yeah, that is a very good question. Regarding the quality engineers as engineering as a method, the method are the same. The method are the same for sure. But the point here, in order to apply the quality engineering in any field, you still need the foundation for this industry, right? So when I'm talking about the manufacturing industry, like let's say plastic company that are producing bottle of waters, for example. So I should have some kind of background about like how this machines it works, what are the technologies this machine have. So you should have kind of background, not in quality engineering, I mean, but your industry in order to implement this tool. And this is not usually the problem, because once you work on a certain industry for 1 year, 2 years, 3 years, okay, I already got understand what's going on, what we do have in the workplace here, what are the machines or the softwares we are dealing with, so I can now start see how I can improve quality engineering. But like jumping from one industry to another industry, is it possible? I would say yes. Is it easy? I would say no, it's not easy, but still require at least fair basics of knowledge to be able to apply this quality engineering tools. But it's not impossible.
Thank you. There's just, I feel like you've answered part of the second question, but I just wanted to ask it just in case there's a little bit more you'd like to share about that. The follow-up question to this is, does quality engineering really depend on domain-specific experience?
No, yeah, the answer basically is no. Yeah, the answer basically is no. But as I mentioned, you need to understand what's going on in your place. So, for example, let me take you to this scenario. Hopefully, it will help clarify this question. Now, I have been working in a plastic engineering company for quite a long time, but I'm mainly continuous improvement and quality engineering person. So now I found a good job in aerospace industry, and they were looking for someone who are into continuous improvement, process improvement. Can I apply for the job? Definitely, you will be able to apply for this job, and your expertise will be appreciated. But can you apply these tools right away from the first day? I believe you need to spend time to understand the new industry first, just to have, I'm not just saying very high level of expertise, but fair experience about what's going on. And then definitely you will have a huge room to apply the quality engineering tools.
Thank you. That's great. I had another follow-up question that came closer to the beginning of your presentation, where you kind of presented the cycle of quality engineering, and you paused in particular around the improvement. And throughout your presentation, you've mentioned that if you've come up with a fix, but it's not sustainable, it's not truly an improvement. And my
Yes.
question to you is, based on your experience within the industry and what you know, even academically, what typically prevents a company, an organization from moving from the improvement portion into the standardizing portion into the sustainable portion of that cycle?
Yeah, there are two things here for this part, and that's a very critical part, honestly, because sometime business owners they got this, honestly, unfortunately. Okay, we have a problem now. Let's try to find a consultation company or someone who can help us with this, and this has happened with me, like for different scenarios. Yeah, we once I got the problem, we start to think about it. They give me some time to just understand this one, and this is related to the previous question. Once I have this, we start to think about what are the right method to apply to find the root cause, and we got the improvement done. Usually, they were very happy at this moment, and they will say, "Thank you, you are good to go." But there are two pieces that we need to consider: how to standardize this improvement, like the way you have done whatever you have done to redesign the process or redesign the operation or redesign the product to prevent this failure and make improvement. This method that you have developed to face this problem, it needs to be standardized. Standardized means it should be very well documented and anyone in your place can apply it, right? And the way of implementation should be concise, to the point, clear, and can be easily implemented. So here I'm talking about implementation. So implementation will not be done without clear standardization. And even if I have standardization and I show people how they would implement it, there should be kind of factors or aspects I need to control in order to make sure that this implementation will not be vanished or will not be non-effective after some time. And that's why we need to look into the sustain aspect. And if you look into this cycle, once I reach to the sustain element in the equation, I should go back again and check, do I still have waste, or do I still have the waste that I used to have in the past, or I might have new kind of waste? And this is the surprising part that I have seen in few incidents, that even people, when they don't care about standardization and sustaining the solution, when they go back again, they come up with different type of waste, and it's going to be similar to the real scenario, the very initial scenario, which I have done nothing, right? So again, two pieces of things: standardization with right implementation, and make sure that you do have some factors and KPIs in action to make sure that you are monitoring and controlling this improvement.
Thank you, Hussien. It's been a great session today. I just wanted to say before we end things today, thank you again to those of you. Oh, there's one more Q&A here. This is a great question. We'll end with this question here. The question is, how do quality engineering tools differ from other tools for continuous improvement?
Yes, that is a good question, because there are many micro credentials and certificates, without showing, like saying any names, that are available online, that they are focusing on lean processes, for example, or lean concept, continuous improvement concept. But the idea is usually, for me, and this is not from my academic experience, but mainly from what I have seen in industry, the most challenging part is not just to make the continuous improvement loop working, but is where to identify the problem, where to identify the waste. And even once you identify the waste and you got bunch of wastes, which one I should start with first, which is make priorities for this waste. So this step looks simple to many people, but it is not simple. And continuous improvement, basically, they are more focusing on the method that's eliminating this waste and trying to kind of sustain and standardize this improvement, but they are not mainly focusing on identifying the problem and how to identify the waste and how to make priorities for this waste before jumping to the improvement and remove unnecessary waste. So the quality engineering is not just focusing on lean or Kaizen or some continuous improvement principles. I can see it this way. It's more a way of thinking. It's more an approach that you can see the story from the very far beginning to the very far end. And this is what is maybe not that much clear when it comes to continuous improvement only.
Thank you. We just have one last question, and I
Yeah.
think we may have time to address it. And this
Yes.
comes from James, and he's asking, what are the differences in strategy on quality assurance for a design-focused organization when compared to that of a manufacturing operation?
Can you repeat the question again, Cynthia?
Sure.
I didn't get, yeah. Okay.
So James is asking, what is the difference in strategy around quality assurance for a design-focused organization versus a manufacturing operation?
Yeah, it's like, again, if I understand James' question in a correct way, so when we are talking about design-based organization, maybe they are not, the final product is not a product itself or a physical product. It might be a service. So usually we look into this things, whether I'm delivering a product or I'm offering a service. Maybe the service is a design solution or design something which is not a physical product. The concept is still of quality engineering can be applied for both of them. As I mentioned here in my ways when it comes to, for example, let me briefly go to the KPIs I believe the KPIs. There are some KPIs that's different when it comes to service industry or versus product or production or manufacturing industry. But the concept at the end of the day, it will be the same, and the waste in the time it will be the same, and like the way even to address the standardization and sustaining the improvement and make priorities for the waste is still the same. But I believe it's more here about looking into what are the right measures or the right KPIs that I need to focus on. That might be different compared to a business that's focusing on production or manufacturing more.
Thank you, Hussien. And again, we'll end our time together now. Thank you again to those of you who have been able to stay and ask questions. Again, if you are interested in learning more about the quality engineering micro-credentials, the QR code is here. And again, our recording will be made available soon on our website. Thank you again, and have a lovely day. Take care, everyone.